Alright, so we're going to be answering the essential question, what is a derivative? And the derivative is best defined as the slope of any line at any given point. So tonight we're going to look at the example of the line y equals x squared, which I've already given a rough little sketch of. So if you look at the equation y equals x squared, the derivative, which was also known as y prime, would equal 2x. And this is by a power rule. And what the power rule is when you're taking the derivative of an equation and you're looking at a certain term that has an exponent, you're going to bring down the exponent and multiply it by the coefficient, and that will be your new coefficient. So in this case, the coefficient is 1. And when you bring the 2 down, that'll give you 2x. And then the new power of the new term will be the power of the old term minus 1, which in this case is 1, but you don't need to write that. So y prime in this instance for the equation will be 2x. Now, if you're looking at it at a certain point to find the slope of the tangent line, say the point is x equals 3, which would be roughly right here. All you have to do now is plug in x. So y prime of 3 would equal 2 times 3, which equals 6. So that means that at x equals 3, the slope of the line is approximately 6. Not approximately, it's 6. So if you draw the tangent line at the point 3, which the tangent line is a line that just sort of barely grazes the point itself and the line, and that's a really rough line, but you'll see that the slope does look to be about 6. So let's look at a little bit more of an elaborate problem. Now I have already gone ahead and graphed on my calculator the equation negative 3x squared plus 4x plus 2. And on the graph, which we're just going to sketch again, from negative 5 to 5 on both axes, the graph looks a little something like this. Okay, so let's look at the derivative algebraically. Y prime would equal, well, let's do the power rule. 2 times negative 3 is negative 6x. 2 minus 1 is 1, which you don't have to write, so that's 6x plus, this is also, you can look at this as x to the first. So you're going to bring down that 1, and all you're given is 4x to the 0. Well, anything to the 0 power is equal to 1. So we're just going to go ahead and erase that x. Okay. And then lastly, you have just the term 2, and it is not really a coefficient. And so you can look at this as 2 times x to the 0 already. So when you bring down that 0 times 2, that equals itself 0. So this is negative 6s plus 4 plus 0. Okay, so this means that to find the slope of the line at any point, you would just plug in the x value to negative 6x plus 4. So let's do that for, again, well, let's do it for x equals 2, which is, on the calculator, it's roughly about right here. X equals 2. So y prime of 2 would equal negative 6 times 2 plus 4, which is equal to negative 12 plus 4, which is equal to negative 8. So when you draw the tangent line, which again just barely grazes the original line itself, comes back out, the slope should be about negative 8, and that appears to be right in this instance again. Now, derivatives can be used in real-life applications when trying to find the rate at which a volume of a tank of water is filling up, or the velocity of an object moving along a line, or something as such.